What's up everybody, Jacob here, and today I'll be demonstrating this 100 watt LED chip, and that's right, 100 watts through this little chip about 1.5 inches by 1.5 inches in size. This thing really packs a punch. I'll show you how I built this, I'll show you how I'm powering it, and finally, I'll show you how bright this thing is going to be.
The centerpiece of our project will be the 100 watt LED chip itself. You can see it has a metal backside complete with multiple holes, which will allow it to be mounted to a heatsink. Speaking of the heatsink, we need a fairly large one. Given that this chip will draw about 100 watts of power, I picked an old CPU heatsink, and I believe it was liquid cooled even, because you can see the copper tubes in there. This thing is going to draw, again, quite a bit of power. In fact, in our case, right around 80 watts, and that will require a decent sized heatsink to prevent heat from damaging the LED. This is our power supply, a switching power supply, 42 volts at 2 amps. It actually used to be a Bird and Lime scooter charger, but now it's going to be repurposed as an LED powering device or an LED power supply. There's a screwdriver to assemble everything together, and we also need just a few bits of wire. And that will allow us to make the connections in our circuit and complete the project. As we get to assembling the LED project itself, the first thing we want to do is simply mount the LED onto the heatsink. This is done, at least in our case, by simply attaching it to the heatsink using just one screw. Because this is only an experiment and it is not meant to be permanent, we don't have to be perfect here, so I decided to just use one screw, and this one screw will be able to attach the LED, the chip at least, to the top of the heatsink. After we searched for the proper position, and it took me just a couple tries, we finally dropped the screw into the LED, and we are going to attach the LED to the heatsink. This ensures that the LED is able to stay fairly firmly fixed to the copper plate itself, and the heat will be dissipated. Next, we're simply going to attach the LED, at least the LED terminals, to pieces of wire. It's very important here that the wire pieces not be allowed to touch the metal of the heatsink itself, because that would cause a short if we were to power or attach the power supply to it. Thankfully, we are able to avoid that problem, and after just a few seconds of assembly, we can attach a couple of wires crudely to the LED itself. Once again, just a little bit of checkup work to make sure that the copper plate on the heatsink will not cause a short circuit. And after we reposition the wires, we're going to be in business. So that's basically how I made this very simple LED. In fact, most of the work is simply really just attaching the LED chip to the heatsink and then also making sure that the wires do not come in contact with the metal of the heatsink. So now that our project is complete, the last thing we're going to do is attach the leads of the power supply onto the appropriate terminals. And when we're working with LEDs, it's very important to remember that polarity matters. And if you don't get the polarity right, the LED will not light up at all. So there's the project, it's finished, and now we're going to go on and do a little bit of testing to see just how bright this thing actually is. As we've already mentioned, this LED is rated for around 100 watts. Just how powerful is that? We'll find out in 3, 2, 1, and I'll just let the result speak for itself. That is one bright light bulb. In fact, the LED is so powerful that the moment it's turned on, it's able to effectively blind the camera. Now, it is important to note that the power supply that we're using is limited to right around 80 watts. So the LED is not technically being driven to its maximum power. It's only getting about 80% of what it could theoretically take. But still, given that LEDs are able to put out around 5 to 6 times as much light as incandescent light bulbs of comparable wattage, this LED being powered at 80 watts should be roughly equivalent to a standard incandescent light bulb driven at 400 watts. Now, it's not very often that you see a 400 watt incandescent light bulb, so this thing's pretty bright. Our next step is to do some testing outside. Since it's a cold winter night with lots of snow on the ground, I figured it would make for a really pretty sight whenever we light up this LED, and also, fortunately, because it's cold, the heat sink should be able to deal with the heat. And there we have it. A very, very bright, almost a floodlight type of a light bulb there. And in fact, we can pick up the light and we can move it around a little bit more. I decided that I wanted to do a little bit of exploring in the property. So here I am walking a bit closer to the camera. Now I'm going to pick the camera up, and you could see a good 60 or 70 feet easily with this light. It is a very powerful one. We have a ham radio tower out back. It's 150 feet tall. You can pretty much see to the very top of that tower. And yes, this is just an extraordinarily bright light. It's like a floodlight on steroids, honestly. You can see all around the property. It's quite an amazing thing. So there you have it. That would be the project all finished up right there. I did make some alterations to the wires so that they weren't hanging out so much from the sides. You don't want the loose wires, really, even if it is just for a temporary experiment. Again, this is a very big heatsink. Came out of an old computer. It used to be mounted to a CPU. And trust me, we're going to need all of the heat dissipating power of that heatsink because this thing draws a lot of energy. We turn it on a final time, the light is going to get extremely bright. In fact, it's so close to the camera that it literally knocks out the camera's ability to see anything else. It is that powerful. And we're only really powering this thing at about 80 watts, so it is an extremely bright LED chip. This is probably putting out somewhere between 400 and 500 watts of 400 and 500 watts equivalent of incandescent light bulb power. And I just kind of feel the LED a little bit more. It's pretty warm. The heat sink is warm to the touch, so yes, it does generate a lot of heat, but it's also really, really cool to have an LED this powerful. Hopefully in the future, I will be able to do more experiments with bright LEDs like this one. Thanks for watching.